Time dilation research yields anomalous data, raising profound questions about temporal physics and the fabric of reality. Geneva, Switzerland, experiments at major particle accelerator facilities, while reaffirming core tenets of Einstein's theory of relativity, have unveiled anomalous data that are triggering a profound re-evaluation of our understanding of time. The confirmation of time dilation, a phenomenon where time slows down for objects moving at high speeds or in strong gravitational fields, has been complicated by unexpected deviations in experimental results, prompting scientists to explore uncharted territories in temporal physics. The primary focus of the research has been on muons, ephemeral subatomic particles generated by cosmic ray interactions. According to Einstein's special theory of relativity, the lifespan of these particles should increase proportionally to their velocity. Researchers have meticulously measured muon decay rates at various velocities, employing advanced particle detectors and sophisticated data analysis techniques. The experiments involved placing detectors along the path of the muon beam, allowing scientists to measure the particle's decay at different points. This provided a detailed profile of the muon's lifespan as its velocity increased. While the overall trend aligned with relativistic predictions, subtle but statistically significant discrepancies have emerged. Specifically, at ultra-high velocities, the observed lifespan extension of muons deviates from the values calculated using standard relativistic equations. These deviations, though minute, have persisted across multiple independent experiments, suggesting they are not artifacts of experimental error. We have conducted rigorous statistical analyses to ensure the robustness of our findings, stated Dr. Eleanor Vance, lead physicist at CERN. The deviations we observe are not simply random fluctuations, they represent a systematic departure from the expected behavior. The researchers have explored various potential sources of error, including detector calibration issues, particle interaction uncertainties, and environmental factors. However, after extensive investigations, they have ruled out these possibilities. The potential for systematic error was addressed by running control experiments, which confirmed the reliability of the measurements. Furthermore, experiments investigating gravitational time dilation have also yielded anomalous results. Using highly precise atomic clocks, researchers have measured the time differences between clocks located at varying altitudes. According to Einstein's general theory of relativity, clocks in stronger gravitational fields should tick slower. The experiments involved comparing the time readings of atomic clocks placed at sea level and at high altitudes, such as mountain peaks. The clocks were synchronized and then left to run for extended periods. While the overall trend of gravitational time dilation has been confirmed, researchers have observed minute variations in the clock readings that cannot be explained by standard gravitational models. These variations, though extremely small, are consistently observed across multiple clock comparisons. We are dealing with incredibly precise measurements, explained Dr. Thomas Richter, a specialist in gravitational physics. The atomic clocks we use are capable of measuring time differences at the level of picoseconds, which allows us to detect even the slightest deviations from theoretical predictions. The researchers are now exploring a range of potential explanations for these anomalies. One possibility is that they are indicative of previously unknown interactions between particles and the fabric of spacetime. Some physicists are speculating that the anomalies could be a manifestation of extra dimensions, which are predicted by certain theoretical models. The possibility that the observed deviations are caused by interactions with hypothetical particles or fields that are not included in the standard model of particle physics is also being investigated. If extra dimensions exist, they could potentially influence the flow of time at a fundamental level, noted Dr. Enya Sharma, a GPS systems engineer, who is now deeply involved in the analysis of these time anomalies. These anomalies could be a window into a deeper reality that we have not yet fully grasped. But another potential explanation is that the anomalies are related to the nature of dark matter or dark energy, which constitute the majority of the universe's mass and energy. These mysterious entities are known to interact with gravity, and they could potentially influence the flow of time in ways that are not yet understood. The impact of these unknown forces could be subtle, but measurable with the precision of current experiments. Dark matter and dark energy are still largely unknown quantities, stated Dr. Marcus Holt, an astrophysicist specializing in black hole physics. They could be playing a role in the anomalies we are observing, and understanding their influence on time could be crucial for advancing our knowledge of the cosmos. The implications of these anomalies extend beyond theoretical physics. If they represent real physical phenomena, they could have profound consequences for our understanding of the universe. They could also lead to the development of new technologies that exploit the ability to manipulate the flow of time. For example, if we can understand and control the factors that influence time dilation, it might become possible to create devices that can manipulate time in a controlled way. We are now at a pivotal moment in our understanding of time, said Dr. Vance. These anomalies are challenging us to think outside the box and to explore new frontiers in physics. The researchers are conducting further experiments to gather more data and to test different theoretical models. They are also collaborating with scientists from various disciplines, including cosmology, particle physics, and quantum gravity, to develop a comprehensive understanding of these anomalies. The quest to unravel the mysteries of time is intensifying, and the scientific community is eagerly awaiting the next breakthrough. The possibility of fundamentally changing our understanding of reality looms, and the data is showing the possibility that time travel may not be just science fiction. And so, while we've confirmed the core principles of time dilation, these persistent anomalies leave us with more questions than answers. Are we on the verge of a revolution in our understanding of time? Could these discrepancies point to hidden dimensions, or perhaps a fundamental flaw in our current models? The mystery deepens, and the quest for answers continues. Thank you for joining us on this journey into the unknown. We'll be keeping a close eye on these developments, and we'll bring you the latest updates as soon as they emerge. Don't forget to like, subscribe, and hit that notification bell so you don't miss our next episode of Incredible News E3. Until then, stay curious and keep questioning the universe. Goodbye for now.